Mr. John Hudson. He's one of our chief architects, global architects for Brocade. But what's really great about John's perspective is he is really one of the key bodies regarding the standards committees tied to the IETF and really some of the core work that's really building a lot of standardized approaches that we're deploying and being at the heart of that evolution. And as we finish up today, John's really going to come and talk about where do we go from here. And obviously, over the course of the day, I'm hoping you found a few topics that you may take home and maybe do a little bit more research on, or maybe foster additional conversations on the back end. But again, we don't see this as a replacement evolutionary scale, but a complementary one. We are on the baseline of a new way of thinking, communicating, and delivering solutions to our IT customers. And with that comes complexity, release, or fear, or however we want to spin it. But it's an exciting time. I've been in the industry for about 20 years, and I've never been more excited about where we're going because there's so many options, so many ways, so many ideas, and we should embrace that. And the question is, how do we start now, be able to digest it, and be able to communicate in a way that's effective to our consumers and to the powers that be as technicians? Keep in mind, we see this as a marathon, not a sprint. It's an evolutionary process, and it's got to start somewhere. And we are going to be on the foundation of that. We have to crawl before we walk. It's amazing how we have a lot of conversations about us trying to hit the home run as technicians. Get me to that nirvana. We want to get there tomorrow because we get all these really cool things that come with it. But as realists, there's going to be a point where we're going to have to just take it easy and let's get that single, then get that double, and then we'll move to third base and then bring it home. Maybe multiple years before we get there, but it starts today. And Mr. Hudson is going to come in and really kind of reinforce that in his own eloquent way. And he is pretty much one of the best dynamic speakers that I've been fortunate enough to listen to. So I believe you will enjoy it just as much as I am. So with that, Mr. Hudson, could you please come up?
All right, let's see what mic's better to use here. Let me put this down. All right, so thank you, sir. All right, well, thank you, everyone, for coming out. For what it's worth, I spent 12 years working in data centers. I know how hard it is to get out and actually do things like this, so we really, really, really appreciate it. And so essentially what I'm going to be kind of talking about is I think we've finally gotten to a point where most of us have some idea where we are. We have at least a more clear picture than we used to of where we want to get to. What's really, really foggy is what's in between those items, right? And what are those transitions going to be like? What kind of things are other customers doing to succeed? And so we're going to kind of talk about some of the things that are driving these topics. All right, so into the rabbit hole. There is, for those of you that have actually been paying attention to everything in the kind of market space, you could probably believe at this point that servers walk on water. The amount of gap right now between what we can do and then what we're saying we can do is, at its kind of normal pace. However, there is this amazing opportunity, and you could hear it in Judson's voice a minute ago, right? The reason why we're all so passionate about this is because we can see what we can do with it longer term, and hopefully that'll become more clear as we move on. So we have our lovely lead disclosure. So just a little bit about me. I'm actually now the futurist and the principal engineer for Brocade, co-chair of the Troll Working Group. Done a lot of work in the ITF as well as ISO insights and so forth. And essentially, one of the things that I'm finding very funny is this whole discussion about software and all the fear and bravado both that go with it. And so one of the things that a friend of mine sent me a while ago, which I loved, was this Radio Shack ad, which I think we figured out is from like 2003 or something. I need to nail that down. Basically, everything in that ad you can currently get on your phone, or it's available on your phone, or it's technology you don't care about anymore, like tape decks. So the fact that all of that has been put into software should help you come to the inevitable conclusion, which is that everything will be done in software. Everything. Now, it might be that what you want to do in software is not performance ready. It's really only good for qualification or feature proving, and so you might need hardware to augment it from a performance point of view. But the whole idea, look at it this way. How many of you have bought a TV in the last year or two? Okay, so I haven't, but when I was at the store, I was noticing that they had all these apps down at the bottom, right? All these little app icons, right? Like for Twitch and this and that, right? And so I was thinking, imagine if you had one of those TVs, and after a week, someone came in and said, okay, well, you like all those little apps? Okay, well, you actually need to go out and buy a physical box for each one of those apps. See, look, that guy just started laughing. This is how people react when I say this, right? You look at it and you go, wait, what? There's no way I would go buy a separate physical box for each one. But I'm telling you, sir, it's way better. It'll perform. You don't care, right? Easy is really critical, right? Easy is really, really important, right? And so the idea that we want to create software instances of everything, it's not a question of if. It's purely a question of when. Now, I will kind of put another bookend on this in that other image is actually a D-Wave processor. For those of you that aren't familiar with D-Wave, it's a Canadian company working on a quantum computer. And so that chip actually, when it arrives in this large box, it takes about 30 days for its temperature to drop to negative 271, which is what it needs to operate. There will always be hardware. Bleeding edge, the really crazy, cool stuff, the stuff where we're really pushing limits of physics and so forth, there's always going to be a Formula One racing team, right? You're always going to have that bleeding edge. No one's saying that's going away. But what we're saying is that for the rest of the world, and once we've proved it in that hardware, we should be moving at the software as fast as possible because of everything it provides, which we'll get in a little into in a minute. Now, this whole trend for me kind of gets wrapped around this concept in that if you look at what VMware did for most people, right? VMware took the time it takes to deploy a server and took it from days and basically knocked it down to minutes, right? Right-click clone, right? That was a pretty epic thing to do, right? And if you were a project manager at the time, you were in love, right? Because this just gave you so much wiggle room, okay? The problem is that it's the weakest link story. What good does this do you if the rest of the chain takes you 6 months? And so what we've had to wait for over these last couple of years is for the rest of this puzzle to get filled out. For networking gear, you have this lovely NFV movement, where from us you have things like Viata, you have the Steel app and so forth, but there's also a lot of other vendors doing a lot of other great things in NFV right now. There's a large movement going on. And the win is very much the same as it was for virtual machines, right? I can deploy a Viata router on my laptop in about 26 seconds, which is longer than it would take for the shipping guy to call me back and let me know where my crate was, right? So even if it performs only 1/4 as well, I don't care. I'll buy 10, right? So it becomes this nimbleness factor that just really whittles into all sorts of things, right? But the same thing can be said for whatever kind of routing and policy you have, and that each one of these things needs to be streamlined. Each one of these things needs to be software enabled in a way that with things like the different programmatic interfaces, not just your kind of standard, API stuff, but just all the wonderful movement of Python scripting and all these things that are evolving. And then the orchestration, to me, becomes the kind of silver bullet in all this, in that if you do all this perfectly and it takes you 6 months to implement orchestration, and in the end you don't like it anyway, then what have you really bought yourself? And the challenge here is that I used to, and it was one of the things I hated about my job, when I ran data centers, I used to have people come to me and they'd be like, oh, I can write this tool to do the blah, blah, blah. And I would say, no, please don't. And you can see the look in their face, I just rip their souls out, And I had to explain to them that by doing that, you're binding me to that vendor. I have enough trouble with my vendors abusing me. I don't need you making it easier, right? And so the problem was it was really hard to write really good tools because essentially the abstraction layer, the standard side of it, had kind of fallen on its face. I mean, for those of you that were around for SNMP, what we have today is not what we intended, okay? By any means. So now with this whole OpenStack movement, we have, Ghostbusters 2. We're going to try again, right? So now we're going to try really, really hard to create this nice standards layer where now I can tell someone who walks up to me, yeah, knock yourself out. If you think you can write that tool, go right ahead and we'll use it and we'll love it, because if the vendor pisses me off, it's okay. I can swap them out and the tool will still work. And that is a critical, critical aspect of this. It's impossible to ask people to develop tools that then binds them to a vendor. It's a very, very dangerous, slippery slope for folks. So when you combine all of these together, right, what you've done is something kind of interesting. Because if you guys remember, when we first started virtualizing servers, we weren't really sure what was going to happen, right? Like, what were we going to do with servers once they were virtualized? Like, what sort of things might happen? And so a lot of things that did occur, things like memory ballooning and all sorts of things, like, weren't necessarily predicted, right? So now we're entering into a new era where instead of just virtualizing one aspect of it, you can actually virtualize the entire data center, right? And what I mean by that is having an application that lives in kind of a virtual container that basically has all of its resources and can provide the resources back that you need. Now, why do I care? Well, because if I could do all that with a virtual server, imagine what I can do with a virtual data center, right? So imagine being able to go into, within my own company, I would love to be able to give each department an actual dev, QA, staging, and production environment, and actually allow them to link them and actually, control them and be able to roll back and forth and be able to do all these things. But more importantly, then to be able to template them and containerize them and be able to say, if sales comes and say, hey, I don't like my network, I can ask, well, whose network do you like? Oh, marketing seems good. Okay, would you like that one? And now they become this software object that I can link, I can clone, I can copy. And so you can imagine getting to a world where you have a lot of small little data centers doing a lot of very dedicated things. But the promise, the hope of it is that we don't know yet. I mean, the truth of the matter is that vendors don't usually come up with the best ways to use their own products. Customers do, right? You guys figure out the really slick stuff to do with our stuff, right? So in many ways, it's a very symbiotic relationship. Now, there's been kind of a trajectory through all this, in that for most of us, when we kind of start out building data centers, we use the human alert network, which is that you build a data center, you deploy an application, user finds an error. What people think happens is the IT comes in and does this all fancy thing, but it's actually probably more convoluted and looks more like that. And then you get some kind of log event, and you correlate that log event to the time that the user complained, and then you wait for the next patient to die to see if you were right. Right? So probably not the best method, right? So then, as you move on, you start thinking, okay, well, let's why is this a problem, right? We did this for years, so why would this be a problem? Well, I'll tell you my personal experience. So I deployed a VoIP solution many years ago, and we finished early. Guys were all excited and everything. We thought everything was fine, but we built the human alert network. So we didn't have any real ties to it, right? So many real any kind of catches or any kind of tags that would say, hey, be concerned about this. Well, what happened was about 6 months later, we got a call from that local director, very upset because his cell phone budget had gone up 300%. For a very sad reason. The users at that site had hated the VoIP solution, but they'd hated it individually because they didn't want to sync the project. And so they all kept their mouths shut and went outside and used their cell phones. And so it didn't matter that I came under budget. It didn't matter that we finished on time. It didn't matter that we thought we'd done well. That was a failed project, right? In every shape and form, right? And it was purely because we relied on a human alert network, and it's not a good idea. It was a very, very, I didn't realize we got all that animation in. I apologize. I could have played through that. I actually put some time into that. So you got the little dancing dude. But the thing was so frustrating was I had a team of people that had felt so good about what they'd done. Like that was before we got that call, that was one of the highlighted projects of the year. We're like, we nailed that one, And then, no. I mean, it was a very, 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 very frustrating experience. So as you move to phase 2, stage 1, you're essentially kind of floundering a bit in that you need to be doing more, and so what you end up doing is just logging everything, right? You go through that same process, and you go, okay, well, we have to be able to learn from our mistakes. We have to be able to learn from what we've done. And so you go through that same process, but then you have a little bit of a loop back in that you start logging everything, and you don't even know why. You're just I remember having conversations with people. Why am I logging this? Don't worry about it. We'll figure it out later. Just log everything, right? We'll get to it, right? Better to have it than not have it, right? We don't care about disk space. And so, but this still involves patients dying, right? This still involves patients dying. Now, there's a lot you can do with this, right? I mean, I had a personal situation where many, many years ago, by looking at 2 years worth of DB loss information, right, I was able to start getting fairly accurate about transceiver failures, okay? And so I was able to go through and kind of do this kind of very kind of careful analysis and do this kind of very kind of careful planning and essentially build this thing out. However, it needed 2 years worth of data. It was phenomenally proprietary. And the problem is that this requires that you know what you're looking for, right? This requires that you kind of know what sort of catches you're going to need to indicate something. This kind of requires that you have a fair amount of innate knowledge about what's going on, which a lot of customers don't necessarily have. But either way, this model still doesn't work because you're still losing patients. Now, as you start getting into analytics, this is where things get a lot more interesting, right? Because now you have an ability to start asking questions, like, why does this happen? So you go through that same process, right? And then instead of just logging everything randomly, now you take everything that you've logged and you basically dump it into a nice analytics engine that allows you to start not just correlating events to what happened, but actually saying, okay, let's start running some reports, let's start doing some questions, let's start seeing what we can pull out of this, right? And this has actually seen some magnificent success. We have some work that we've done with VMware's vRealize, which if you guys aren't familiar, the previous version was called VCOps. It's a great tool. It actually allows you to baseline your own reality and then differentiate from there. It's a very good way of doing it. And so we've done a lot of work to integrate with that. But in the outside world, we've seen a lot of other interesting things. For example, Comcast gave a presentation at Nanog 55 where they showed that they could find DNS problems in their network faster using Twitter than they could any tools they had developed in-house, right? And so I started asking, like, well, what did you guys do? Well, what they did is they baselined Comcast sucks. And they look for outliers, right? And if you got one 4-block region where people hate Comcast 10 times more than they did yesterday, there's your problem, right? Now, why does that work? Well, because the same reason why you don't go to the doctor until you're dying, right? Calling Comcast support, if you've never done it, is not pleasant. So you're only going to do it when really, really bad things happen. But there's a lot of little things that happen that inform, right? And so this is a way for them to catch it. I've been told that the CDC will do the same thing for disease outbreaks and so forth. This is an inferred method, but it allows you to start asking some really interesting questions and start looking at some very interesting patterns and saying, okay, how do we get indication? How do we start using things like social media? How do we start using things like all these different tools to get to that resolution much, much, much faster? This idea of essentially an inferred model where you basically can tell all this information about what's going on without a tremendous amount of telemetry on that actual device because you're looking at all these outside criteria. And the truth of the matter is that we all litter data all over the place all the time that actually infers intent. And if you're not at least trying to capture that to provide a better response to the query, you're not really doing a whole lot to elevate how you're serving your customer. And this sort of model is, I would say analytics is where a lot of people are trying to get to today. The problem with analytics is analytics requires that you have questions, right? You have to basically have some idea what you're going for. And so you can run the situation where after you kind of debugged it and you got it all down, you know that there's more you need to do, but you don't know what, right? You don't know what direction to take it in. And that's essentially where we believe machine learning comes into it. Because now you have the ability to take that same, kind of analytics data set and feed that to a deep learning engine that now can start telling you things that you didn't even know to ask, right? And so if any of you have ever done a project in this, I can always remember talking to somebody, I can always tell whether they have, because I asked them this one question. I asked, what did you find out that was really weird? And usually people grin at that point and give me a great story, which I love. And so the one I'll tell you is this lovely woman from a large insurance company. Runs all data centers for this large church that you would know. And so I asked her this, and she grinned, and she goes, we like fishermen. And she goes, and not like the mild guys that just do it once in a while, and not the professional fishermen, but like the guys that have other jobs, but like a couple times a year they actually go on like dedicated fishing trips. They're really into it. Turns out those are our best customers and our most profitable customers. And I was like, and so do you know why? And she laughed and she had not a clue. But I can tell you this: my guess is in about 2 years you're going to start seeing some dedicated advertising to a lot of bait shops, right? Because they're going to play with this. They're going to see. The thing is that another great example I can give is this use case where they basically looked at, in a supermarket, buying behavior of beer. And they discovered that, at least in this one area, that most of the men buying beer during the week had children, and the one during the buying beer on the weekend did not. And so what they did is they had to put the beer on a shopping cart and had to move it from one side of the supermarket to the other for this period of time. Without changing pricing, packaging, advertising, they saw a 16% increase in sales. All they did was make it easier for the people that wanted their product to find it based on analytics, right? So this is a really, really, really powerful way of doing it, but the analytics requires you to know what to ask. The machine learning allows you to start taking data sets that you don't really know what they might be able to inform and start asking those open-ended questions. And this is where we believe things can start getting very, very interesting. Now, the best example I can give of this today is probably Google. Google did this fantastic project, and I kind of have a snapshot of it here. But what they did is they looked at a bunch of data as far as how they can predict environmentals within their data center, right? They basically wanted to look at things like what sort of exterior factors might impact a data center's model, right? Meaning that, why do you have one data center that has the same cooling, but, how much impact does that ambiotic, outside deal with? And so I won't kind of go into all the details, but what they did is they came up with this concept of PUE, which is total facility energy over IT equipment energy. And they basically put this through a learning project where they looked at all these sort of data sets, and I think I zoom it up here in a second so that we can actually read it. And essentially what they did is they put this together and they said, okay, now that we know all this information, what can we do with it? And so essentially what they were able to do is essentially go in and prove their model, be able to actually learn from those data sets and actually show exactly what was happening in their real world environment. And that essentially outside air does have a massive impact. And so they've actually changed some of their models and changed some of the way they're doing things to account for this. Now, one could say, well, duh. But it doesn't work that way, right? The truth of the matter is that different places have different solar cycles, different kind of conditions, and you can build in places that mean you don't need much cooling ever if you're really carefully selected your location, right? And so, but this is still fringy stuff, right? This is still not what most people are doing, but this is where we firmly believe that things are going to evolve too. So essentially you have this very clean kind of evolution, right? Human network, you log everything, you get into analytics, and then possibly go into machine learning. And so what this also means is that if you have people poking around about machine learning and you don't really understand why you'd need to use it, it's possibly because you haven't done enough analytics yet to feel the pain that then gets answered by machine learning, right? There is kind of this step process that goes through. But where you want to insert yourself into this paradigm and where you want to jump in and how you want to approach it is completely independent, and that's something that you guys can control. Now, a lot of people think there's a stage 4, which is find a new job. I could not more viciously disagree. And the reason why I'll say this is because we've seen trends like this before. How many of you used to run Sun Gear? I was a Sun sysadmin. I love that stuff, man. My dad even worked at Sun. I used to go to the company picnics every year. And I remember I had this 6900, and it was great. It was on an earthquake plate, so you could bump it, and it would move around by itself. And I got 6 hours of downtime a year, contiguous. Took an hour and a half to shut it down, hour and a half to boot it. So I got patch time. And I was running Linux, and I had to be I had a hard time imagining this movement. And it wasn't technology. It was fear. It was really my company, the board, is going to vote to take all the Oracle financials off this nice, solid Sun box that has CRCs between chips, for Christ's sake, and move it onto a Dell? I mean, no offense to Dell, but come on, really? But here's the thing. The factor difference between the data points, I mean, you're talking about, 3,200 BTU down to what, right? You're talking about 1,200 pounds down to what, right? So you ended up with such a massive difference in not only the cost, but the way it was implemented, the way it was done, that essentially, well, as we know, I was quite wrong. Sun did not survive. Well, I mean, I take that back, storage tech. But the thing is that was not a technology thing, right? That was a economics thing. It was an emotional thing, and it happened a lot faster than any of us thought. So assuming that we're not going to see the same thing again probably wouldn't be wise, right? Now, will it play out exactly the same? Of course not, right? But here's the thing. Why would I want a 3,200 BTU router if I can build a bunch of little guys, right? You don't meet many 800-pound ants out in nature. So wide and shallow is actually a good way to go. Now, in fairness, what a lot of people will point out is, well, that wasn't fair. It wasn't one-to-one. It was one-to-many, right? It wasn't one Sunbox to one Linux box. It was one Sunbox to 10 Linux boxes. Yeah, I agree. And I have no problem with that happening again, right? I none whatsoever. And matter of fact, that's our movement is in our software projects is to essentially start really kind of striping things across multiple boxes. So will details be different? Yes. Will it play out like this? Yes. Because in many cases, what a lot of this is about is multi-tenancy. It's about the fact that I want to be able to give everyone in my house their own fridge. And when they open it, they only see their food. I never see anyone else's tofu. They never see any of my, whatever it is, right? And what they each don't know is that all of their fridges actually collapse down into one physical fridge that I actually own and pay for, right? And that sort of slicing of the resources is what is driving a lot of this movement, because that's what gives you that granularity. That's what gives you that ability to go down. But you have to at least acknowledge that we're going to make mistakes. We are going to make bad calls. We are going to think things are going to go one way and not another. I don't mean, we as in me, but we as an industry. Because I can tell you that there were a lot of people not too long ago that really thought, and I was one of them, that this is what we were expecting. Basically a policy-based system where I could have VMs that basically roamed around the countryside on their own and looked for greener grass on their own and knew how to look for sunlight and kind of like teach your kids how to cross the street sort of model, right? The problem is that in practice, there are context switching issues. There are all sorts of interesting practical issues with this. And there are some people doing it. But if you look at what's been happening lately, you can see another trend occurring, which is that what you're more likely to see is something like this, where you have your software data center, right? But that software data center has still those concepts of data flow. And so you still have the perceived issues of north, east, and west, south, right? But now, if each department has multiple data centers, or each customer has multiple data centers, you're not just looking at one northeast, west, south. You're looking at a bunch of them, right? And then you're going to take all those data centers, and you're basically going to take them and you're going to apply them to a cluster of boxes, right? Well, exactly how those data centers fall, where they lie as far as what resources they're using, there's going to be no consistency of left and right, let alone angle, right? And so what you end up with is something probably not unlike this, where you have all these different data centers that are kind of placed across your cluster of devices, and exactly what resource they use and where they go is going to be dependent upon some level of policy, right? And so in this world, you need to have a little faith, right? Because you are talking about a little bit of a leap, right? You are talking about a little bit of a fundamental change in how you're doing things. But what it does also provide is the kind of resiliency that we want, right? And this kind of comes down into this little comic that a friend of mine sent me a while ago. And I'll give you guys a second to read it. But if you've ever been a Unix sysadmin, this might be one of the funniest things you've ever seen. And the thing is that when you're working in these data centers, you're just asked to do stuff, right? I once time got asked to move a reactor. You're asked to do all sorts of crazy stuff, and you just have to make it happen, right? And so what you need is Legos. You need lots and lots and lots of Legos, right? And what we're trying to give you is a lot more Legos, just doing it in software, so you can model it, you can control it. Because ultimately, no one believes that your jobs are going away. Because let's face it, I mean, you guys have to do a lot of crazy, crazy things that most of us don't even pay attention to. Now, we've tried to essentially look into some of the programmability of this. We've looked at different ways to handle it. We've been doing a lot of work with Python. We've been doing a lot of work with Puppet and Chef. And we believe that essentially what you're going to see is you're going to see an evolution of network operators, not to developers. There's a big difference between a coder and a developer, right? I have no interest in doing regression testing. I don't want your feature request. There is no release date, and don't ask me for a patch, right? I write tools, okay? And that's a different thing. But it's a very powerful thing, and a lot of it can be distilled down to this one basic concept, which is if you ever do anything in production by hand again, I'm going to shoot you. Okay? And how you containerize that, your ballgame, right? Whether you want to do it with Python or Bash or whatever else. But the point is that this is how you start to evolve. You start getting more programmatic. You start getting more repeatable. You start getting more, essentially modeled in. And so, once again, what ends up dominating, whether it's Python, whether it's some Puppet Chef environment, we don't make that bet. We have to essentially, implement it where we can. But ultimately, what we believe we're trying to get to for all of you is something like this. And I'm going to find out who did it because I feel bad. I keep using his image and I don't give him credit. But this little pizza as a service image is brilliant. Because what it shows is this normalization of services where you can basically shift them however you want, right? So you can basically say, okay, I want this many resources being done by the vendor and this by me. But in this environment, I want this much done by me and this much done by the vendor. And so you have total control over your risk analysis. You have total control over how much exposure you have. But to get to the point that I can order pepperoni and I'm going to get a slightly different pepperoni all across the country, but we can all agree basically what a pepperoni looks like, right? And so now what I can do is I can go order a pepperoni pizza in another place, and I make it something a little different, but it's being close enough I'm going to be happy, right? And to get to that model, we need a lot of normalization. We need a lot of consistency. And that's what that software is going to bring for us. Now, as we move forward, we're going to get much better at doing this as well, in that if you look at the controller movement, aside from the programmability to it, there's the how does the controller learn? How do you teach it? How does it learn new things, right? And this is where I also believe the analytics and the big data comes in, because ultimately, I don't want to be shifting bandwidth at an inflection point because of something that happened 2 years ago. I want to be pulling live data on what those users are doing right this minute, and I want to be shifting load now. I want to be it'd be nice to actually meet the customer's need before they call, right? And so, but this starts getting into all sorts of other things. You can start digging into, medical and weather data and all sorts of things. And what you're doing is you're significantly better serving your customer, right? You are basically going to be much, much better at meeting their need because you know more about what their problem is, right? And so essentially what we're trying to do is keep you guys where you are, right? You guys are epic in what you do. I mean, I still try to explain to my wife sometimes like what it's like to be in a production data center. And it's very, very hard to do. It's very, very hard to explain to someone who's never done it before what it's like. You guys are rock stars. And what we're trying to do is give you more Legos so you can continue to be rock stars. And with that, that's the Dog and Pony Show. So thank you very much for sticking around. We do appreciate it. Thank you. And I think we have some time for Q&A, yes? Yes, we do. All right, cool. So, and please, I mean, even if it wasn't something on here, if you just have a question about what Brocade's doing or a shift you're seeing in the market, I'm happy to talk about, anything you guys want. So, feel free to, ask away. My favorite color is blue, so.
So I noticed you're doing something with Puppet Chef. Are you looking at Ansible and SaltStack as well?
Yeah, but I got to be honest, that's a part of the process that just kind of sucks right now because for us, it's a huge lift, right? For us to really not just do it half-assed, but actually really do it, right? It's a big development effort. And so we have to hedge some bets as to what we think is going to do it. And so I'm hearing Ansible come up a lot more often, so I think that's going to happen. But I got to be honest, time will kind of determine which one of those actually kind of bubble up to the surface and which stay there. I mean, pretty far along. I mean, we've gotten to a point where, I think there's very little that you can't automate. And I'll be honest, there's not a lot of customers using it yet, right? Because it's all pretty new stuff. But I mean, it's to the point where the VCS platform is all about the zero human network.
Do you have predefined workflows built, or do you have a library of recipes and cookbooks and things like that?
In process. No, I don't think we've actually. I think right now an account rep can actually get you like some early stuff, but the goal is to have a much more developed environment. But we're not there yet. Part of that too is that debate is the resources, right? Because you want to be doing those repositories for the ones that are going to win, right?
John, I was curious about, I know we've had some conversations about trying to consolidate a lot of those Yang data models that are out there in a place that we can easily access them. Is that still a conversation that's reaching your ears of trying to do something like that?
Yeah.
They make those data models available to the masses?
Yeah, and it's interesting to seeing how this has evolved, because I think what we're looking at in-house is actually patching that with software. It's basically, one of my friends, Matt, has basically written a tool that basically kind of takes care of a lot of the differences in the Yang model and kind of blurs them from the person actually using the API, so it creates kind of a standard layer. And so that may end up being the better approach. Time will tell, but essentially we are very committed to Yang, and we really believe in it, and we're going to be doing our best to make sure it succeeds. And that's not to say Yang is awesome, right? If you guys have played with it, it's got its issues. But we all have to agree on something and march forward. So, that's how we got Ethernet, right? So, all right. Well, hey, thank you very much, everyone. Really, really appreciate your time.